Here's a slightly bigger diagram on its side so I can draw on it and identify some key information. So we're told that A, B, C, D, E, and so on has 10 sides, which means it's a decagon. I'm asked to calculate the sizes of angle ABC, so this one here, and angle BQP, so this one here. Right, a couple of ways for the first bit, ABC. First of all, we could do the number of sides minus 2 times 180 divided by the number of angles. This is a regular decagon after all. The 10 and the 10 here cancel. 80 plus 64 is 144. So that is angle ABC. The other way to do it is to do exterior angles. Always add to 360, divide by 10 to get one exterior angle, and then do 180 minus that, which also gives 144. Let's keep going then. So we know that we've got 90 here and 90 here, which means this angle is going to be 180 minus 144 because I've already subtracted 180 from 360. These two must add up to 180, the ABC and the qB3. So that is 36. And then we're left with an isosceles triangle. And if I just draw it out, we've got B, P, Q. These are necessarily the same because they're identical squares. 36. So 180 minus 36 takes us back to 144. But this time we're going to divide by 2 because there are two equal angles here, which gives as our answer 72. So that is angle BQP. So that was part A. Now we're asked to generalize for a regular polygon with n sides and work out these same, well, the ratio of AB, angle ABC to BQP. This time, we've got our number of sides minus 2, or let me call it capital N, times 180 divided by n, which when I expand the bracket gives me 180n minus 360 over n, or 180 minus 360 over n. So that is going to be angle ABC. Note again, we could have got this by doing exterior angles, add up to 360, so divide by n to get the exterior angle and then do 180 minus that. And also, it's a nice way of showing that the two, how the two link together and how they must both be the formulae for the interior angle sum and the exterior angle sum, or interior angle plus exterior angles 180. Like that's how we can show it. Okay, next up then, we've got this angle again, angle qB3 is going to be 180 minus this because these two add to 180, the ABC and the qB3, because angles are on a point of 360 and these two are 90. So 180 minus 180 minus 360 over n. And when you've got a bracket like this, you just expand it and basically multiply through by minus 1. So it becomes 180 minus 180, but then there's a double negative plus 360 divided by n. So in fact, that angle is the same as the exterior angle. So now I've got to do angle BQP will equal 180 minus 360 over n, but I'm going to be dividing by 2 again because it's an isosceles triangle. Now I could simplify this, or I can just write them straight as a ratio because I can see this one is just half of ABC. So let me just check what the ratio was. ABC So angle BQP is going to be 180 minus 360 over n to a half 180 minus 360 over n. This I can just divide through by these because they're the same. So 1 to a half or 2 to 1. Doesn't matter how many sides the polygon has, it will always be 2 to 1. And we saw that up here we had 144 and 72. So the angles will change, but the ratio will stay the same. Just say if you wanted, you could cancel this down to 90. So divide 180 by 2, and then 360 over n by 2, which becomes 90 minus 180 over n. And then use the ratio there. But I think it's just, yeah, a good shout to do it from here. Well done.